Morning, everybody. Here we go again. Let's talk about sampling and population today and talk about why it's important to generalize and what that can do for you when you're looking at research. Okay, population, when we're looking at population, we're talking about the overall amount of people within a group that you're trying to study. So that could be students at Westville North. The population could be the state of Ohio. The population could be the United States. And I know you've heard that term a lot of, what is the population of? Fill in the blanks, okay? So this is going to be the group of which that we want to be able to glean information from. Within that, because many times those groups are so large, you need to take a sample or a subset of the population to be able to run your study to get a good generalized idea of what the overall population is like. And we'll take a look here in a moment about two different ways to be able to do that, okay? So once you get your sample, then you can kind of start to make inferences or generalizations about the population at large. So representation and generalization. So representation is making sure that everybody from the population, as best you can, is represented in your study, okay? And again, we'll talk about two different ways of doing it, but to get what it looks like, you see the large pie slices over there with the population broken down however you see fit. To the left would be a representative sample. So you see the smaller groups are still represented in there, purple, yellow, red, or orange, whatever color that may be, all represented in there. But then on your unrepresented sample, you're missing some, right? You're missing, it looks like, either yellow or orange and purple. So not represented. And then a generalization allows you to do stuff like make an inference as to how the overall population might react based upon the theories of your research. So two ways of doing this. One, you can random sample, drawing names out of a hat, picking, ID numbers, etc. What this one does, it does eliminate some bias, because you have really no control over who ends up in your study. It does still allow for generalization, and it's quick. When you're looking at research, that might be one of the most important factors, is the speed at which you can get something done. The cons, it may not accurately represent all the subgroups, because you can take a sampling of, say, our building, and you can miss out, your random sample could be all males. Okay, they could be all seniors. They could, you name what the subsect would be, and you can miss out on different groups. Okay, so that would be a con of random sampling. The other way we can do it is we can do some stratified sampling. This way, you're taking a look at the different strata or the groups within a population. That could be, again, age, race, gender, you name it, but those are strata. And then you would make sure that the percent of those populations are all represented. Okay, so if 10% of the population are over 6'5", you'd make sure that no matter how many people you had in your sample size, that 10% of your sample size had humans over 6'5". Okay. And again, it allows for generalizations. You can run your study, and then you can come up with ways to explain your results as it would refer to the entire population. The problem with this one is it can be very time consuming to make sure you find folks that fit those molds that you need for your subgroups that fit into the percentage base of your sample size. Okay. So here, finally, again, I'll post notes, as always, annotated and unannotated. You probably have to go to the unannotated to check out the videos, but here you can see kind of how some researchers use sampling techniques to count deer. It's really kind of cool.